Hi everybody, welcome to Socsci10 discussion number 4. This is a redo because I made an error in the first discussion 4 that I uploaded, and I just want to kind of set the record straight. I updated the slide a little bit, and let's get into it. So I had a meeting with a student earlier in the last week, and they were a little confused by Skew and how it affects some of the statistical measures that you'll be dealing with. And I just wanted to kind of clarify that, both for the homework that we had on Friday and going forward. So one of the things is, when you're talking about Skew, really, what are you learning here? So the whole point of Skew is really to give you kind of an intuitive understanding of where the different statistical measures are going to show up on a graph. And how is that useful? Well, if maybe you're calculating out the median or the mean, and you graph your distribution, you see they're not showing up in the right area given the skew of the distribution. So you know right away that maybe you have an error in your computation. And if you're looking at that intuitive understanding of where these things will be, these statistical measures will show up on a graph distribution, kind of give you understanding of how to interpret what you're seeing when you're looking at various papers, or like I mentioned, they give you the ability to double check your work at a glance to make sure things are showing up where you intuitively should expect them to. And so what we're trying to understand then with the skewedness is to get that intuitive understanding of how things are organized. So let's just talk quickly about some of these elements, these statistical measures, and how they interact with skew. So we know what the mean is. The mean is the average, and you can see here I've got the formula again. We've got mu, which is a Greek letter that looks like a U with a tail in the front, and it equals the summation of x, where x are all the elements in your sample, divided by n, where n is the number of elements in your sample set. Okay, so you can hear for this sample, you can calculate out there are 11 items. If you add them all up, you get 55, and you divide by 11. That gives you a mean of 5. Right? Mu equals 5, and we all know how to calculate averages as students. It's something that you do. And but another way to get a statistical measure is the median, or the middlemost value present. So you sort all the values in your samples, and you take the one that's in the middle. And if you have an even number, it could be both numbers in the middle are means or medians, right? But the median was going to be the middlemost value in your sorted elements, your sorted element list. And finally, like the last one, the easiest one to understand is the mode. It is simply the most often occurring value. And you can see there I've got highlighted that it's going to be 3. So now, how does this all relate to skew? Well, skew is where the tail of the distribution points. So looking at the graph below me, you can see you have a left skewed graph and a right skewed graph. And people will think when you're looking at these distributions that really where this distribution is located, where these elements are really located, is where the mode is. That's where the most number of elements is located, and the median is going to be the area where you have an equal number of elements on either side of the median, right? So you can also say, all right, well, the median is the balance point of the area under the curve, right? You have 5 elements that are going to show up in the area on the left, 5 elements are going to show up in the area on the right, and the median is splitting that down the middle. So this is really where you imagine, where this distribution is located on the number line. Now, you're going to notice that it kind of sweeps out to the left or the right. That's called the tail of the distribution. And the direction that that tail points, whether it's to the negative end of the number line or the positive end of the number line, that is how we're going to label the skewness. Left skewed, or negative skewness, is where the long tail is running down to the negative end of the number line. And on the right skewness, or positive skewness, is going to be where the long tail runs down to positive infinity. So now what that means is that the mean, now remember the mean is the weighted average, right? So you're going to take the value of the element itself, okay? And you're going to sum these up and divide it to get the weighted average. And then the median is where you have equal number on either side of the median, right? And the mode is where you have the most often occurring element. Now, when you're looking at these graphs, you will see that The tail, it pulls the median away from the mean, away from the median, away from the mode. It spreads them out. Why is that? That's because the mean actually takes into account the outliers of the distribution. It gives them more influence over its own measure, the measure of the mean. Whereas the median, if you've got one outlier way out on the tail, it is not going to really affect how the median, where the median is, as much as the mode. And of course, the mode is simply the highest point on the graph. The highest point on the graph is the most often occurring value, right? And as long as you don't have a value that increases more, that has more elements than that value, the mode's not going to change at all. You can have as many outliers at the tail end of the distributions as you like. It's not going to affect the mode as long as you don't get more copies of the same value than you have of the mode that you already have. So it's least affected by, where that top point is. It's not going to change no matter how many elements you have out the tail end of the distribution, unless one of those ends up having more elements of the same number. Then that will be the new peak, down somewhere on the tail. But in this case, you can see that the mode is not affected by outliers. The median is affected somewhat by outliers. And the mean takes their full weight, the full weighted average of the outliers into consideration. And so that's why you will see the mean is pulled in the direction of the tail more than the median and more than the mode. And remember, the skew is where the tail points. Is it pointing negative, right? As it is in the left graph. The tail runs down to the left graph. The fatness of the tail is on the left. In the right graph, the right skewed graph, it's the positive skewness because the tail is running off to positive infinity. And so this image here really helps you get an understanding of where these three statistical measures are going to show up on a graph that's skewed. And you should get an understanding. So maybe you're computing something, you're looking at a distribution, you're computing the median and mean, and maybe it violates this idea here. This idea that you're going to have this organization. Maybe the mean is showing up in between the median and the mode, even though you have a skewed distribution. Well, something's wrong, right? If you have a simple distribution that's got one lump, as these distributions do in the graph, and you get that reorganization when you're doing your computation, you know that you've made an error. You know that there's something wrong, or maybe there's more. You have a more sophisticated graph. Maybe there are multiple humps. You have multimodal, right? More than one mode. You could have more than one mode, right? You have one hump over here. It's very high. It's the most often number of occurring elements, but maybe the second most often number of occurring elements is far away. So you'll have a valley in between. You have multimodal distributions. That often happens in grading, where you will get a lot of people will cluster the very highest level, and then a lot of people are going to cluster typically at the average level, and those are typically your two modes. You'll have a multimodal distribution that occurs very often in grading, right? There's also some measures of variance here, variability, that I also put in this graph. Two, you're just going to know, you've probably seen it before, but we'll talk about it again. It's going to be this variance and the standard deviation, right? And don't forget, you got to know Chebyshev's inequality. So the Chebyshev inequality puts a bound on how many elements can be outside of the standard deviation. So this is an important measure here, the standard deviation. How do you get it? Well, standard deviation is just a sigma element. It's another Greek letter. It looks like an O with a tail across. The way you get that is by computing the variance, right? And taking the square root of the variance. That's how you get the standard deviation. And you compute the variance by taking every element of your data set and doing a difference between that element and the median and the mean. Right, so we computed the mean of this element, and I didn't write it out here, but we can do it real quick. So let's take a look at this real quick. So we know that for this distribution, that at the top, that we had a mu of 5. The mean is 5. Okay, so we've got 3. So looking here, the difference of each of these elements from 5, and we're going to add it up. So going from the left to the right, we have 2, so the difference is 3. So we take 3 plus 3 2's is 6. It's going to be 11 plus 0, right? Plus 1 2 is going to be 13. plus 2 more is going to be 15. 15 plus 6 more is going to be 21. And then 21 plus 4 more is going to be 25. So we have a total of 25 divided by 5, which is divided by 11. So let me pull up a calculator here real quick. And let me just do this. 25 divided by 11, which is the number of elements in the data set. It's going to be 2.27 repeated. So you have 2.27. Then we take the square root of that. That's the variance. 2.27 is going to be the variance. So what we want to do now is we want to take the square root. Where is my square root here? Let's see. 2.27 to the 1 divided by 2 is going to be 1.5. So the standard deviation is going to be 1.5. Okay, and what that means is that if you look at the Chebyshev's rules, within 1.5 of the median, so that'll be the mean. So the mean is 5, so that'd be 6.5 to 3.5, so 3.5 to 6.5, right? It's like 70%, 68 something or other. It's going to occur. There's going to be a certain number of elements that have to occur within this range. Otherwise, the mean itself would have shifted. So make sure you know Chebyshev's. Understand how to calculate the variance once you know the mean, right? You got to understand how to calculate the mean. And then you get the standard deviation by taking the square root of the variance, right? And understand how skewness affects where these statistical measures, mean, median, and mode, are going to show up in the graphs. That way you have a good intuitive understanding of what skewness is. All right. I hope you guys did well on the test this week. Like I said, this is just an update video because of some error that was in the original video. And talk to you guys next week.